All right, so we are graphing an inequality here, two variables, and we just got finished talking about what the solution region is, and that would be all of the points that satisfy the given region, okay, the solution region. But what we need to do is we need to start with the boundary, and that is, in this case, the line that separates, the greater than or the less than solution region. So we are first of all going to graph the equation version of this inequality, okay? So step one, if you're doing steps here, step one, graph equation version of inequality. So that is 2x plus 3y equals 6. Now, we're going to find some points, and the easiest points, you know what, the easiest points to find out are the intercepts. Why do I say that? Well, if you let x equals 0, we've got 2 times 0 plus 3y equals 6. So that gets rid of this whole term. That makes it a 0. And 3 times what is 6? Y is 2. So we've got a y-intercept of 0, 2. I'm going to put that right there. Just a little dot on 0, 2. I know that that's 1 point on my boundary line. I'm also going to test out what y equals 0 looks like, because that's going to give me my x-intercept. Well, I get rid of this whole term because 3 times 0, right? So 2 times what? 2x equals 6. When we divide by 2, we got x equals 3. X equals 3. And there's my y-intercept. So that's easy for anybody to do. We get 2 points and plot them. And then we draw as best we can. Well, we're going to wait for a second here. Instead of drawing our line right away, we have to look to see what the boundary looks like. So in this case, we have less than or equal to. So that means that the equal to part is part of the solution. So I am going to draw a solid line connecting these 2 points. And if it didn't have the or equal to, if it was just a less than, then I would make a dashed line on the boundary, a dashed line. So I'm going to try and do this freehand here. So forgive me if it's not very good. A solid line because it's or equal to, and you're going to use a ruler or a straight edge if you can, please. So you're not shaky and messy like me. But so you draw a line like this. Okay, so this line is part of the inequality. Now what I need to do is I need to figure out which side of the boundary to shade. And again, we're talking about all of the points that satisfy the inequality. So it's either going to be all of the points above the line, above or to the right of the line, however you want to think about that. It's either going to be all those points, or it's going to be all the points to the left or underneath the line. Okay? Because again, this is the boundary. So think about the boundary of a country, a border. Okay? If you're on one side of the boundary, you're in one country. If other people are on the same side of the boundary as you, then you're all in the same country. So if I had a group of people and I asked one of you which country you were in, I would assume, because you're all on the same side of the border, that the rest of you would be in the same country. Okay? Get that? So we're just going to basically try and find, I'm going to test a point. Okay, so testing a point is going to be probably the easiest way to determine this. So, and you know what? You know what's a really good point to test is 0, 0. If 0, 0, the origin, if that is clearly on one side of the line, like if the line goes through 0, 0, you got a problem. You're going to need to figure out, just pick another point. But if 0, 0 is clearly on one side of the line, then that's a good one to test, okay? So step 1 is graph. Step 2, I would say, would be to test a point to determine feasible region. Oops, do they call it feasible region for you? No, solution region, sorry. Feasible region, I think they call that in a different course, my bad. To determine a solution region. Or actually, it might be in this course just later on the chapter. Solution region. Okay, and again, try 0, 0 is a good one. Try 0, 0. Why is that a good one? Watch this. 2 times 0 plus 3 times 0. Is that less than or equal to 6? Well, super easy. We've got 0 plus 0. So is 0 less than or equal to 6? Yes, it's less than 6. So guess what? The point that we checked is in the solution region, and so are all of the other points that are in the same country, right? They're all in the solution region. So guess what? What you do now to identify the solution region is you now shade that side of the line. And so I'm just going to do this. I'm going to shade it. So with your pencil or whatever, you just shade. Now, it would be a good idea to extend your line to the edge of the grid or whatever if you have, so you can shade everything. It doesn't have to be perfect. You just shade that side of the region, and that should be the solution region. Now, the second part of this question says to determine if this point, negative 2, 4, is part of the solution. Okay. Well, a couple things you could do, and I'm just going to erase some of this shading. What you could do is if you drew your boundary line properly, like really carefully, you could look and go negative 2 up 1, 2, 3, 4. And it looks like, if I drew this really carefully, it looks like it's on the top side of the line. It looks like it's not in the region. But again, I don't know if my line is really perfect. So if you can see that it's in the region or not, you can clearly say it is or it isn't. This one appears to be not part of the region, okay? But did I draw this line really carefully and really well? How else can you check but to put the x and y values into the inequality and see if the inequality is true, okay? So I'm going to, for b, I'm going to test negative 2, 4 like this. 2 times, what's the x value? Negative 2. That's plus 3 times the y value, which is 4. And I'm going to basically see if this is true or not. If it is true, it's part of the solution. If it's not true, it is not part of the solution. So I've got negative 4 plus 3 times 4 is 12. Is that less than or equal to 6? Well, negative 4 plus 12 is actually 8, isn't it? So is this true or not? 8 less than or equal to 6? Nope. That is not true. So we would be right to say that the point 2, 4 is not part of the solution, negative 2, 4. Negative 2, 4, right here. So good news, my shaky line is still good enough to clue me in there to if that's part of the solution or not. All right, so again, shade the solution. Just quickly, kind of with your pencil, whatever, just shade the side of the line that contains all the points that are in the solution. 2 ways you can check if a point is in the solution region, and that is 1, look at the graph, see what side of the line it's on, or 2, test the point and see if the inequality is true. Okay, any questions there? Yes. Okay, question was, let's go over again how you determine the solution region. So what we understand is that the solution region, because this is the boundary, you have to be in one country or the other, right? If this is a border. So are these people in this country, are they part of the solution or not? So you can take any point and quickly test the inequality. That's what I would do. And I tested 0, 0 here, but you could take any other point. So for example, you could go, let's see, 1, 2, 3, 4, 5. Okay, let's try this one. This is 5, 0. It's always nice to use a 0 because something times 0 is always 0, so that's really nice. But let's check 5, 0. So that's going to be something like this. I'll put this in black. It's going to be 2 times 5 plus 3 times the y value is 0 should be less than or equal to 6. And again, you're just going to test. Program crash. Yeah, okay, it's gone. Anyways, 2 times 5 plus 3 times 0. Is that less than or equal to 6? We're testing the point 5, 0, which is clearly on one side of the line. And so I've got 10 plus 0. Is 10 less than or equal to 6? And you would answer yourself, absolutely not. So that means that the other side of the boundary line would be the solution region. And you could take and test as many points down here in this shaded region as you want, and the equation should be true every single time. Okay? That's the best way. Now listen, some people say, oh, it's easy. If it's less than, you just shade underneath the line or to the left of the line. That actually, you'll find, that happens a lot of times. But you can't always do that. You can't just say, oh, less than is shading underneath. It's less than. Not always. Not always. And you just have to, you just have to take my word for it, because we're going to start to do curves of different, like parabolas and different things. So it becomes a little tricky, like what's the left side or what's underneath, really. I mean, you know, most of the time a less than would probably be to the left of the line or underneath the line, but you should check every time, okay? Does that clear that up? Okay, good? Yes. Anybody else have a question? All right.